In this video, we're going to talk about how to know whether something's polar or nonpolar based off of its Lewis dot structure. So for example, linear, well, first off, the difference between polar and nonpolar. Polar means that there are slight charges in the molecule because you have one atom that's more attracted to the electrons than the others, and they're offset by some sort of difference. Nonpolar means that it's uniform throughout the entire molecule, and so there's no slight charges, and it's neutral altogether. Now, for example, linear. I have this carbon and these oxygens. Now, these oxygens are pooling on the carbon equally. There's not one that's going to beat the other one, so this would be a nonpolar molecule. Now, this one here, I have my boron and 3 fluorines. Again, these fluorines are pulling equally on the boron, so this would be nonpolar. Now this one, however, this is my NH3. While it does look like the hydrogens are all pooling and there's not one that's stronger than the other, I do still have these electrons up here at the top. Now those do count in polarity because they have their own space. So not only is it 3 hydrogens that's pulling on the nitrogen, it's also 2 electrons. So this nitrogen, okay, is more attracted to the electrons than the hydrogens are. Therefore, it's going to be a polar molecule. Same thing with this water here, okay? The oxygen also has these electrons as well, so they count when dealing with polarity, and so this is a polar molecule. This one, however, here, you have 4 hydrogens pooling equally on the carbon. There's no other electrons, there's no other different atoms, then it's nonpolar. However, if we were to replace one of these hydrogens with, say, chlorine, then it would be a polar molecule because it'd be different then. And that is how you know whether something's polar or nonpolar.